This video is on other chiral compounds. Not all chiral compounds have a carbon with 4 different substituents bonded to it. We can have other atoms with 4 separate things bonded to them too, ending up with a chiral center. For example, this quaternary ammonium salt, or this silane. But that's not all. We can also have pyramidal atoms that do not invert, which therefore end up with a tetrahedral structure with a lone pair in one position, such as this phosphine and this sulfinic ester, something like that. And you may be wondering, what about like any amine? Well, the amines, the lone pair actually can flip back and forth, kind of like an umbrella inverting in a heavy wind, if you picture that. Whilst the phosphorus and this sulfinic ester cannot do that. Allenes are another type of chiral compound, depending on what substituents they have, of course. This one we can explain with the molecular orbital theory. Recall that 2 double bonds bonded to the same carbon have to be orthogonal to each other. Therefore, you pretty much just end up with this extended chiral center. Next are the biphenyls. These ones, as you can see, look very symmetrical, but in fact they are twisted because, as in this case, the hydrogens are in each other's way, causing the molecule to twist. Once we have a twist, it can either be a left-handed twist or a right-handed twist, creating chirality. We would refer to this as an axially chiral molecule. And then finally, we have helical molecules, where you just have these rings forming this corkscrew shape or a double helix shape. Speaking of which, a double helix, such as DNA, is most likely a chiral structure. So just be aware that chirality can arise in some strange places, not just necessarily a carbon chiral center.